The discovery of Proxima b, an exoplanet orbiting the closest star to our solar system, sent shockwaves through the scientific community. Located just 4.2 light-years away in the Alpha Centauri star system, Proxima b sparked intense curiosity and hope. If life existed anywhere else in the universe, surely this small rocky world orbiting a red dwarf star was a promising candidate. At first glance, Proxima b appeared to be within the habitable zone, where conditions might allow for the presence of liquid water. That one detail ignited dreams of alien life, future space missions, and even potential colonization. However, as we peeled back the layers of Proxima b's environment, we found a much more complicated reality, one filled with extremes, dangers, and mysteries that still leave scientists puzzled and excited. This rocky exoplanet is approximately 1.17 times the mass of Earth, which places it in a similar category in terms of composition. But while Earth orbits the Sun in a stable 365-day cycle, Proxima b whirls around its host star, Proxima Centauri, in just 11.2 days. This is because Proxima Centauri is a red dwarf, smaller and cooler than our Sun, which allows Proxima b to orbit much closer while still staying within the so-called habitable zone. However, this proximity comes with a price. Red dwarfs are notorious for their stellar flares and magnetic activity. Proxima Centauri frequently unleashes bursts of radiation hundreds of times stronger than anything our Sun emits, bombarding the nearby exoplanet with potentially deadly ultraviolet and X-ray radiation. These flares can strip away atmospheres, making it incredibly difficult for life to take hold, let alone survive. Despite these dangers, Proxima b has some intriguing potential. One of the most fascinating theories is the possibility of a terminator zone, a narrow band between the planet's permanent day side and night side. Because Proxima b is most likely tidally locked, one hemisphere always faces the star while the other remains in perpetual darkness. This leads to temperature extremes, scorching heat on one side and freezing cold on the other. But in the slim twilight region where day meets night, conditions could be more temperate, possibly allowing for liquid water to exist, an essential ingredient for life. The idea of a habitable terminator zone has opened a new avenue of thinking for scientists exploring exoplanet climates. It challenges the classic Earth-like Goldilocks zone model and suggests that even planets with harsh global environments might still harbor niches where life could thrive. The James Webb Space Telescope, JWST, launched with the goal of exploring the earliest galaxies, has become one of our most powerful tools in the search for life beyond Earth. With its ability to peer through thick clouds of gas and dust, JWST offers unprecedented clarity in observing distant exoplanets and their atmospheres. Recently, scientists used JWST to study Proxima b, hoping to detect atmospheric signatures that might indicate life or at least habitability. What they found shocked everyone. The telescope detected fluctuations in the infrared spectrum coming from Proxima b's vicinity, patterns that some scientists interpret as potential chemical reactions in the planet's atmosphere. More astonishingly, these patterns resemble those caused by gases like oxygen, methane, or even phosphine, substances that, on Earth, are linked to biological activity. Though far from conclusive, these findings reignited the question: could there really be life just 4.2 light-years away? But the story doesn't end there. Proxima Centauri's activity poses serious challenges for long-term atmospheric stability. Any gases observed might not last long enough for life to use them. JUICE's data showed strange periodic dimming in the light around Proxima b, which could be signs of massive auroras, indications of strong magnetic interactions between the star and planet. These intense events could periodically sterilize the surface or prevent the development of complex molecules needed for life. On the other hand, the very existence of these auroras suggests that Proxima b might possess a magnetic field, possibly offering some protection for its surface and atmosphere. Earth's magnetic field, after all, shields us from harmful solar and cosmic radiation. If Proxima b has a similar defense mechanism, the potential for habitability increases significantly. Scientists are also considering whether Proxima b might have a thick atmosphere, perhaps even denser than Earth's, that could buffer some of the radiation and help distribute heat from the day side to the night side. This would prevent one side from becoming a scorched desert while the other turns into an icy wasteland. Climate modeling based on data from JWST suggests that if such an atmosphere exists, it might be able to support weather systems, cloud formation, and even precipitation in the terminator zone. The possibility of a stable water cycle, even in a narrow band of the planet, would be revolutionary for our understanding of life's resilience. Adding further intrigue to the picture are hints from other observations, including the Atacama Large Millimeter, Submillimeter Array, ALMA, which previously detected strange signals near Proxima Centauri. Some speculated these were artificial in origin, perhaps alien technology. Though these claims were eventually attributed to human-made interference, they sparked intense public and scientific interest, reminding us just how significant even minor anomalies can seem when we're looking at a planet so close to home. Even if Proxima b doesn't support life now, it raises critical questions about planetary formation and survival around red dwarf stars. These types of stars make up the majority of the stars in our galaxy. If life can't exist around them, that drastically narrows the places we might find it. But if Proxima b or planets like it do support life, even in limited zones, it opens up countless possibilities. JUICE's discoveries also challenge our assumptions about what constitutes a habitable world. We used to think that only planets with stable sunlight, moderate temperatures, and Earth-like conditions could harbor life. But as we learn more about extremophiles, organisms that thrive in boiling acid pools, frozen wastelands, or under immense pressure, we're beginning to realize life might adapt to a variety of conditions, many of which are nothing like those on Earth. What's more, the chemical signatures detected in Proxima b's atmosphere raise the tantalizing possibility of a biosignature, evidence of life processes. But scientists remain cautious. These chemicals could just as easily result from volcanic activity, lightning, or other non-biological processes. Distinguishing between life-generated gases and geological or chemical ones is one of the biggest challenges in astrobiology. That's why continued observation is crucial. Future missions, including ground-based observatories like the Extremely Large Telescope, ELT, in Chile, will play a vital role in cross-verifying data from JWST and filling in the gaps. And then there's the ultimate question. If there is life on Proxima b, what kind is it? Are we talking about microbial colonies clinging to rocky crevices in the twilight zone? Or something more complex? Creatures adapted to extreme radiation, strange climates, and perpetual darkness or daylight. The truth could redefine our understanding of biology, evolution, and what it means to be alive. Even if life doesn't exist on Proxima b, the planet still teaches us about survival against the odds. It shows us how planets evolve under constant cosmic bombardment and how atmospheres either hold on or vanish. It may even help us understand our own planet better, how fragile or resilient Earth is in the face of stellar activity. The discovery also serves as a powerful motivator for future exploration. Proxima b lies within a reachable distance for future interstellar probes. Concepts like Breakthrough Starshot aim to send small, light-propelled spacecraft to nearby star systems, including Proxima Centauri. These missions could potentially reach Proxima b in a few decades and give us our first close-up view of an alien world. It's the beginning of a new era in space exploration, one where distant planets are no longer just dots of light but places we can study in detail, perhaps even visit one day. The hope of discovering life beyond Earth has always driven science forward. With every new image, every dataset, every whisper from the cosmos, we get closer to answering the oldest question humanity has ever asked: are we alone? For now, Proxima b remains an enigma, an alien world bathed in radiation, balanced on the edge of possibility. But it also represents hope. Hope that somewhere out there, under a dim red sun, life might be holding on. And that we, the watchers from Earth, might one day reach out and say hello. With the continued help of the James Webb Space Telescope and the next generation of astronomical instruments, we are no longer simply gazing into the night sky. We are beginning to understand what lies beyond it. And if Proxima b holds even a glimmer of life, That revelation would not just change science. It would change everything.